Hey, this is Don from Padlock Technologies again with another video. This time I got asked about NAT64 and could I demonstrate NAT64. So if you don't know anything about NAT64, basically what this is going to do is allow communication from an IPv6 network to an IPv4 network, but it doesn't do it the other way around. Basically, the traffic has to initiate from the IPv6 network to the IPv4 network. It is not going to be traffic initiating from the IPv4 network to the IPv6 network. Because what we're going to do here now, I don't have a DNS server in here, but what we're going to do is we're basically going to translate our IPv6 address into an IPv4 address that the IPv4 network understands. And then those returning clients are going to basically reply to a pseudo node in the network, and then that address is going to revert back to the IPv6 address. Now, the reason why I say pseudo node, because technically this uh, node doesn't exist in the IPv4 network. So think of it as like a proxy, right? So it's going to be IPv6. It gets NATed to an IPv4, which will act like a proxy because the return traffic will talk to that IPv4 address that technically doesn't exist in the network, and then that will get translated back to the IPv6 network. So this is very basic lab here. 3 routers, like I said before. You can simulate a lot of very super advanced topics with 3 or 4 routers. You don't need to simulate a complete network to actually get this going. So right now, the only thing we have here is IPv6 addressing and IPv4 addressing. I'm running EIGRP, and we have these networks that we're going to talk to. So let's go to the NAT64 router just so you can see. Let's look from an EIGRP perspective. Let's see if our neighborship is up here. So we got a neighbor, and then we do show IP route EIGRP, we see 4224 and 8888. Those are my simulated networks that we're going to talk to from the IPv6 network. Now, one of the things that you will see is this command called NAT64 stateful prefix. That prefix is what we're going to use to translate our IPv6 address to the IPv4 address. So without that, we can't do that, and it's a /96 address, right? So it's going to fall within the range of the /64 because obviously it's a longer match. And if you look here, we have our /64 on the IPv6 side, and then we have our 96, and then we have our IPv4 here. So let's start configuring. So the first thing, just so you can validate here, let's do show IPv4 interface brief. So you see we do have IPv6 there, and let's just make sure we can ping ISR v1. So here, ABCD D 19999 colon, I think it's 2. Okay, so we have reachability to ISR v1, and our NAT64 router is .1, and the ISR v1 is .2, and then ISR v3 is 10.10, 10.1.1.2. So if I can ping 10.1.1.2, that's the IPv4 side. Let's just make sure we can ping those other loopbacks there, because I'm using those as loopbacks. All right, so we have IPv4 reachability and we have IPv6 reachability. So now let's configure NAT64 to make sure that IPv6 can talk to IPv4. Now there is going to be something on the communication to IPv4 that I'm going to warn you about if you try to do this right now. Most of the times, typical corporate engineers are not going to have to do this, but service providers may do this. But if you're just working for a company, something like that, rarely are you going to configure NAT64, but it's something to have in your tool belt. So the first thing we're going to do is we are going to enable NAT64 on both the G1 interface and the G2 interface. So we just go NAT64 enable. All right. And now that brings up the NAT interface. I'm just going to slide this out just a little bit more. So we have NAT64 now is available, or it's enabled. So the next thing I usually do is I'll do the access list here. So we'll do the access list, and I'll just say IPv6 users, and that should be IPv6 access list actually. IPv6 access list, IPv6 users. All right, and we're going to permit. Now, what we're going to do is we're going to permit the translation to happen for our main/64 subnet. So that's the 2001 ABCD 1999 :/64 any. All right, so we're good to go there. Next thing we need to do is we are going to create the NAT64 prefix. So we go NAT64 prefix stateful, and then we are going to do, let me just make sure, yep, we're just going to do what? And I'm doing this all off memory, by the way. It's been a long time since I did NAT64. 1999, and then we're going to give it that other subnet, 2CAF :/96. All right, so that now says, hey, once we configure everything, our main subnet, our original IPv6 subnet, is going to get translated to this subnet when it's trying to talk to an IPv4 subnet, right? So technically, how this is going to go from a packet or flow standpoint is I am going to get translated to that address, which then, well, technically the IPv6 side is going to get translated to IPv4, and then when it responds back, it's going to get translated to this subnet, all right? And then that's going to communicate back to ISR v1. So now that we have that there, we go NAT64, and I believe it's pool. Let's see here, NAT64, blah, 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 v4 pool. Sorry, v4 pool. We're going to call this IPv4 pool. And I'm going to just pick an address in the IPv4 subnet. So I'm going to do 10.1.1.5, and I'll go to 10.1.1.10. So now that is the IPv4 pseudo node addresses that the IPv6s will get natted to, so I can communicate with the IPv4 side. And then when it comes back, they will communicate with that fictitious IPv4 address, and then that will get natted to an IPv6 address so that the IPv6 can talk to it, right? So we're basically faking it on the IPv4 side as well. So now that that's there, we need to go NAT64, and if I remember, it's going to be 6 to 4 list, and this is going to be IPv6 users, and then pool, IPv4 pool, and I'm going to overload it, so that means I'm going to do pat for this. All right, so all that's there. So let's see if I go show run section NAT64. Here's everything for the NAT64 side. So I got the stateful address that I'm going to be communicating to on the IPv6 side. That's going to get converted to the IPv4 pool, whatever address is in there, and it's going to be overloaded. Now, you might see this example, and what you need to realize is you still need to have a default route pointing to the NAT64 gateway, because you need to tell it where this address is, right? Because what you're going to do is basically on the NAT64 side, or on the IPv4 side, let me explain this. On the IPv4 side, it's going to you're basically you're going to turn into this address on the way back. So on the IPv6, and you'll see when I ping it, it'll make more sense when I ping this. I'm not pinging any of these IPv4 addresses. I'm going to ping something in this subnet here on the IPv6 side, and then you got to convert this IPv4 to an IPv6 address, basically embed it in the IPv6 address. Then that will get translated to one of these when I go to communicate on the IPv6 side. So it's going to reverse it. So IPv6 will turn to IPv4, and you'll see I'll have like, I think 1.1.1 is 0101. You'll see at the end. And then my IPv6 address is going to actually turn into one of these. And when I show you the NAT64 translations, it will make entirely all the sense here, right? But that's the basic configurations. Now, what we got here from an IPv6 side is we have no routing, but we have IPv6 enabled. So show IPv6 interface brief. All right. Now, if we do show IPv6 route, I just have a default route here that points to my NAT64 router. Okay. So what I'm going to do, and hopefully this works, so this is live, we'll go ping IPv6, and we're going to go 201 ABCD 199926AF, and then I believe it is 0101 0101. I believe that's the address for 1.1.1.1. So as you can see, what's going to end up happening is I'm pinging it /96, but I'm embedding 1.1.1.1 at the end. Now that's going to get converted from an IPv6 standpoint. When you convert it to IPv4, it's going to be 1.1.1.1, and then my IPv6 address is going to get converted to an IPv4 address. In this instance, it's probably going to be 10.1.1.5. And then when I go to communicate back from the IPv4 network, I'm going to go and talk to 10.1.1.5, which technically is going to get translated back to the IPv6 address that I came from. And then I'm also going to get reverted back to this address here so I can talk to the IPv6 network. So we're going to test this out. We're going to see, and hopefully I did not mess up the IPv6 address. Yeah, I had a funny feeling I may have messed up the IPv6 address. Let me see. It might need an extra colon. And there you go. So what I did was I didn't add an extra colon, so that was my fault. But this is 1.1.1.1. So this is IPv6 that doesn't know anything about IPv4. And I was able to communicate with it. And to verify that that the translation did happen, let's go here and we'll do show NAT64 translations and see what happened. And there's our translation. So as you can see, I tried to ping, this is the original IPv4 address, and then the translated IPv4 address, all right? And this is the original IPv4 that it tried to talk to. And as you can see, it got translated back to this IP address, this IPv6 address. So when I tried to ping 1.1.1.1, the original got translated to this. And then obviously, if I run this backwards, sorry, let me run this backwards. So I ping this address, right? That address got translated to this 1.1.1.1. The original IPv6 address was this. This was router 2, or router ISR v1. That got translated to 10.1.1.5. All right. So when 1.1.1 tried to communicate with 1.1.5 or 10.1.1.5, they got translated to the IPv6 address of that address was what 1.1.1 got translated to, and then 10.1.1.5 got translated back to the original address was route ISRv1. So yeah, that is the translation, and the reason why you see ports is because I did overloads. Right. So let's try again for a different IPv6 address. So we're gonna do, I believe, I don't remember what I think it's 4.2. I think it's 04020402. I think that's what it is. I could be wrong. Or 0204. I could be wrong on this. Oh, actually, I was right. All right, so this got translated to the 4.2.2.4. So if we go back to our translations here, and there you go. So when I tried to ping this address from the IPv6 network, it got translated from an IPv4 perspective to that. And since the NAT router knows where that is because of EIGRP, it just forwarded that traffic. On the way back, when 4.2.2.4 tried to communicate with 10.1.1.5, that got reverted back to this address, right? And then on the way out, it got this is the destination. It got reverted to this destination again. And then on the way out from the IPv4 network, it reverted it back to its IPv6 equivalent so that the IPv6 network can talk to it. Again, this is NAT64. This is from the 6 network to the 4 network, not the 4 network to the 6 network when it comes to originating traffic. So hopefully that that cleared up what NAT64 is and what it's used for. Normally, you would have like a DNS, IPv6 DNS server, so you don't have to do the IP address. You would just ping the FQDN, and then the IPv6 address would get it, and then it would get the NAT64 router would do its translations. Very simple to set up, but it's a weird concept to understand. Again, if you're a corporate person, would you probably see this in your lifetime? Probably not. And I'm saying probably not because I haven't really seen NAT64 in the field when it comes to on the corporate side of things. On the service provider thing, you'll probably see that a lot. But if we're talking about enterprise, you're probably not going to see it as much. So if you like stuff like this and you appreciate seeing things like this, please do not forget to share, comment, like, and subscribe to the channel. I appreciate every subscriber. I appreciate all the questions I'm getting. And I'm just grateful for having this channel and be able to, teach a lot of people stuff that they probably didn't know or, refresh some memories. This is Don from Padlock Technology again. Thank you and have a nice day.